Hello guys, hello guys. We have came to another video of machine learning series for beginners. Okay, आज हम लोग पहले लेक्चर में हम लोग देखे थे बेसिक्स देखे थे इंट्रोडक्शन मशीन लर्निंग का। अब हम लोग एक एक एल्गोरिदम पे जाएंगे। ठीक है, आज से हम स्टार्ट कर रहे हैं सुपरवाइज्ड मशीन लर्निंग का एल्गोरिदम्स। ठीक है, अब हम मैं मशीन लर्निंग को दो तरीके से देखती हूँ। ठीक है, एक है मैथमेटिकल अप्रोच और एक है प्रैक्टिकल अप्रोच। ठीक है, मैथमेटिकल अप्रोच में क्या होता है, लीनियर जो एल्गोरिदम्स है वो लोग मैथमेटिकल फॉर्मूलाज डेट पे, ठीक है, देखता है कैसे वो एल्गोरिदम काम हो रहा है। ठीक है, और प्रैक्टिकल में देखते हैं क्या, उस एल्गोरिदम को हम कॉल करेंगे और कैसे प्रिडिक्ट प्रिडिक्ट करेंगे। ठीक है, अब ये बेसिक कोर्स है। ठीक है, हम लोग का बिगिनर के लिए कोर्स है। जब हम लोग और एडवांस कोर्स बनाएंगे तब हम लोग मैथमेटिकल अप्रोच का डेप्थ में देखेंगे क्या हो रहा है क्या नहीं हो रहा है। ठीक है, बट इस कोर्स में हम लोग मैथमेटिकल अप्रोच भी देखेंगे, प्रैक्टिकल अप्रोच भी देखेंगे। ठीक है, बट उतना डेप्थ पे मैथमेटिकल अप्रोच नहीं देखेंगे, बेसिक से कर देंगे। ठीक है, जो स्टूडेंट को अच्छा समझ में आएगा। और इंटरव्यू में जो क्वेश्चन पूछा जाता है यहाँ से सब हो जाएगा इस बेसिक्स कोर्स से। ठीक है, तो पहला प्रॉब्लम स्टेटमेंट है वो है लीनियर रिग्रेशन एल्गोरिथम। ठीक है, हम लोग के पास सपोज एक डेटा सेट है। ठीक है, उस डेटा सेट में डेटा है। ठीक है, मेरे पास एक डेटा सेट है, मेरे पास एक डेटा सेट है। उस डेटा सेट में बहुत सारा डेटा है। अब उस डेटा में से कुछ इंडिपेंडेंट फीचर रहेगा, कुछ डिपेंडेंट फीचर रहेगा। और इंडिपेंडेंट फीचर क्या है, हम लोग का बहुत सारा हो सकता है। डिपेंडेंट फीचर एक ही होगा और वो हम लोग का आउटपुट होगा। ठीक है, अब हम लोग एक मॉडल बनाएंगे, सिंपली मॉडल। ठीक है, उस मॉडल पे हमारा पहले मॉडल को हम ट्रेन करेंगे हम लोग का ट्रेनिंग डेटा से। ठीक है, पहले हम लोग मॉडल को ट्रेन करेंगे। ट्रेन करने के बाद हम लोग मॉडल को कुछ इंडिपेंडेंट फीचर देंगे और वो हम लोग को एक डिपेंडेंट फीचर आउटपुट प्रेडिक्ट करके देगा। ठीक है, अब जो डेटा सेट में डेटा है, ठीक है, इंडिपेंडेंट फीचर और डिपेंडेंट फीचर, हम लोग इंडिपेंडेंट फीचर देंगे मॉडल को, आउटपुट में डिपेंडेंट फीचर हमको मिलेगा। ठीक है, अब हम लोग देखते हैं। ठीक है, सपोज हम लोग के पास फीचर्स है, एक फीचर है फीचर 1 और हम लोग के पास आउटपुट है। ओके, फीचर में कुछ डेटा दिया गया है और आउटपुट में कुछ आउटपुट है 2.5 2 3.5, that means it is continuous. So if we see that it is continuous, then we will apply regression algorithm. If it is continuous, then we will apply regression algorithm. So here it is linear regression algorithm. Now suppose this is my feature and this is my output. Okay, now if I draw a graph, ठीक है, if I draw a graph, simply a graph, if I draw, okay, so these are my data points. Suppose, so draw a graph between, this is my dependent feature, that is the, okay, this is dependent feature. I say this is my output, this is my output. Okay, wait for a minute. This is my output. I draw in y-axis, and in x-axis I have my dependent feature, that is the feature 1. Suppose now in feature 1 these are my data points. Suppose these are my data points. It is spread here and there. Okay, these are my data points. Now in linear regression line, what we need to do, we need to draw a best fit line which is passing through the origin, like this. This is my best fit line. Now why it is my best fit line, and what is this best fit line, we need to understand that. Okay, what is this best fit line? Now if you see, these are my data points, small data points. This is best fit line. If I draw a line, I take this distance from this point to this line. I take this distance from this point to line. I take this distance, this distance, this distance, this. Okay. Now I computed the average of this distance. Average. I will find the distance between this point and this line is minimum. So because of this distance between this line and the point is minimum, so it is known as this best fit line. Okay. Now if we see this line, we can say that this line, in straight line formula we have y equal to mx plus c. Okay, we have this formula y is equal to mx plus c. We can also write this formula as h of theta x equal to theta 0 plus theta 1 into x. What is this theta 0, theta 1? Okay, see, h theta of x is my y. Okay, theta 0 is my coefficient. We see, if we see the straight line equation, y is my this y-axis, x is my x-axis, m is the slope, and c is the coefficient. Okay, like here, theta 0 is my coefficient, h theta is my y, x is my x-axis, and theta 1 is my slope. Okay, so we can write this formula y is equal to mx plus c also. We can also write this formula h theta of x is equal to theta 0 plus theta 1 into x. Both the formulas are right. But to go deeper into the mathematical approach, we will choose this formula. Okay, same as this. So the terms are getting changed. H theta y, theta 1 is slope, theta 0 coefficient, x is same. Okay, this is my same. Or C, we can also tell C also as intercept also. Okay, this is my intercept. So in linear regression, the main thing is what? My data points will be given. We will draw a best fit line such that the distance between the points and the best fit line is minimum. Okay, and why it is called linear regression? Because y is a linear function of x. If you see this formula, y, this is a linear equation, and y is a linear function of x, so it is called linear regression. And what is this linear regression? The main concept is here is the best fit line. Okay, now to calculate the best fit line, we have one term known as cost function. Okay, what term is there? That is cost function. What is this cost function? Okay, cost function is that we represent cost function as j of two variables, that is x and y, and sorry, of two variables, that is coefficient and the slope. So coefficient is theta 0, slope is theta 1. Okay, and the cost function formula is 1 by 2m summation of m I equal to 1 to m. Okay, now h theta of x minus y whole square. Okay, now I will explain this formula. This is my cost function. I denote the cost function as j theta 0 theta 1. This h theta of x is my predicted point we get from this formula. H theta of x we get from this formula. This is my predicted point, right? Predicted point. This is my predicted point, H theta of x. And y is my real point. Real point. And 1 by 2 is given for the derivation purpose. That means if we try to derive the formula, huge mathematical derivation is there, and from the derivation 1 by 2m is coming. Okay, and main thing is this, we need to see this, because this is my thing, main thing, that is the predicted point minus real point is the cost function. Now if we calculate this cost function, we will find the best field line, we will get the best field line. Like, sir, how we will get the best field line? Okay, I will explain to you. Suppose my equation is h theta of x theta 0 plus theta 1 into x. Theta 1 is my slope, this is my intercept, this is my y. Okay, now suppose my theta 0 is 0. Suppose I am doing is 0. So my equation will become h theta of x is theta 1 into x. Okay, now if I use this cost function at different theta 1 values, use my cost function as different theta 1 values, okay, I will get a graph. So this is my theta 1 and this is my cost function and this is my theta 1. Now at various theta 1 point I calculate the j theta 1. Okay, and my graph tends to be like this. If I see this formula and my j theta 0 theta 1 formula, okay, I take in the data set, I take various points and I find at different theta 1 values. First I find theta 1, then theta 1 is 0, theta 1 is 1, theta 1 is 2, theta 1 is 3, and when these are my theta 1 values, and in j theta 1 I find in this theta 1 values I find my j theta 1. Okay, and I will get like this a graph, and if I join these points, I will see a graph like this. This graph is called as gradient descent. gradient descent. Okay, so I take various theta 1 values, I calculate the cost function, I plot the graph theta 1 values. Okay, and here if we see that here is my original theta 1 value from this, not original but the theta 1 value from where we will get the best fit line. This is my theta 1 value. Okay, this is my theta 1 value. Now if I use this theta 1 value and I draw that graph, I will get my best fit line. Okay, so this, from here I get the theta 1 values. Now where is the theta 0 value? If we see theta 0 and theta 1, it will be looking like a three-dimensional figure, so it is not possible to explain the three-dimensional figure like this. So imagine that theta 0 is 0, so I use that theta 0 is 0, I calculate the theta 1 value and show you the gradient descent. Okay, I show you the gradient descent. From the gradient descent we will get the theta 1 value. From this theta 1 value we will draw the best fit line, so it will be best fit line. Okay, so here in gradient descent, this point is also called as my global minimum. Global minimum. Okay, now suppose global minimum, so this is my theta 1, but how I will get this theta 1 value? I am standing here, suppose this is my point, I need to go here. How I will go here? If I go like this, I take big steps, I will be lost here and there. I will not get, I will not be able to reach to this point if I take big distance. Now if I take small distance, then I will be able to reach here. Okay, if I take small distance like this, take take small distance, I will able to reach here. So I cannot take big steps to reach here. This small steps, and these small steps we calculate using another algorithm known as the gradient descent algorithm. Gradient descent algorithm. Okay, I come to this global minima to get the theta 1 values. So this gradient descent algorithm, there is also a formula, that is theta 0. Here theta 0 is theta 0 minus alpha times 1 by m h theta of x minus y whole 1 minus y. Okay, and my theta 1 becomes theta 1 minus alpha times 1 by m h theta of x minus y into x. So this is my theta 1 value and theta 0 value. This is my gradient descent algorithm. Descent algorithm. Okay, now all of you have got puzzled where from where it's coming. So I am giving you the gist of this. Okay, I have my data points. I take the data points, okay, and plot it in the form of a graph. This is my data point. Now I try to draw a best fit line. For the best fit line, my formula becomes h theta of x is equal to theta 0 plus theta 1 into x. Okay, this theta 0 is my intercept, this is my y, and this is my slope, it's my m. To draw the best fit line, I need to get the value of theta 0 and theta 1. For this, getting the value of theta 0 and theta 1, we used cost function. That is the cost function. From that cost function, we calculate the value of theta 0 and theta 1 and try to draw a graph between this theta 0 and theta 1. I try to draw a graph. From that graph, I get a gradient descent algorithm, gradient descent curve. From that gradient descent curve, I need to reach the global minima, that is here. I am standing over here. I cannot take big steps because big steps will jump here and there. I will not able to reach. I need to take small steps. For the small steps to reach to my global minima, I have to use this algorithm, that is the gradient descent algorithm, theta 0 and theta 1. When I reached here, I got my theta 1 value, I got my theta 0 value and theta 1 value. Now I will put the theta 0 and theta in the equation, and I will draw this line, and I will get my best fit line from here. Now, if we see, we have uses one independent feature, that is f1, that is the y. Okay, there may be another more independent features I have told, y1, y2, y3. Okay, the same approach. First, we need to calculate the cost function. From the cost function, we will draw the graph. We will get the gradient descent curve. We will use the gradient descent algorithm to come to the global minima to get the theta 1 0. But the only difference is that we will get a 3D curve, and the other things are same. We will get a 3D curve. So I think that we have understood the linear regression algorithm. Okay, and now we will see the linear regression algorithm, the performance. What is the performance? What is the accuracy? Okay, for calculating the performance and the accuracy of the linear regression algorithm, we have performance matrix, or performance. For performance of regression algorithms, we use two methods. Okay, for any regression algorithm performance, use two methods. One is R2 score, another is adjusted R2 score. Adjusted R2 score. Now, what is this R2 score and adjusted R2 score? Okay, R2 score is nothing, but there is a formula of R2 score. Is that R2 score is equal to 1 minus y minus y cap whole square by y minus y bar whole square. Okay, this is my formula of R2 score. Now, what is this y? This is my real point, and this is my predicted point. This is my predicted point, and this is my real point. Okay, this is my real point, and this is my mean y bar. Using this formula, we will get my R2 score. We will get our R2 score. Okay. Now, if we see that mean, this term will become smaller. This is an high term. This is a high term. High term means we will get some bigger values. If we calculate, we will get some bigger values. And if we calculate this real minus predicted point, we'll get some lower values. So lower by bigger is what? Lower. So 1 minus lower, and we will get a big number. Bigger value. Okay. So how will this R2 score help in the performance of the algorithm? If we see, suppose there is my feature 1, I calculate the R2 score, it comes up become 90%. There is my feature 2, I use two features, f1 and f2. Now it's become 92%, so it is increasing. If you see, it is increasing. Okay, now if we use, suppose in my features there is a name, my data set contains name, age, output. Now I have my data points. This name feature will not have some impact on this output feature, will not have any impact. But if we calculate this f1 f2, my adjusted r2 score will increase by 1% or 2%. Okay, so to prevent this we use another term known as adjusted r2 score. Okay, now what is this adjusted r2 score formula? Using the 1 minus r square or r2 sorry, n minus 1 by n minus p minus 1. This is my adjusted r2 score formula. R2 score we know, n is the number of features and p are my features. Here my features, or this is n is number of data but not features. Okay, this is my data points. This is my data points. Now what is the difference between adjusted r2 and r2? Okay, what is the difference? In r2 score we are getting a big value. Now if I see n minus p minus 1, I will adjusted r2, I will get some small values in my answer. Suppose I have my feature 1, it is 85%. I introduced another feature f1 and f2, my adjusted r2 will get decreases. Using this formula, my adjusted r2 will get decreases, but in case of r2 we see that it will get increasing if we add more features. So this is the difference between r2 and adjusted r2. We use the r2 score only to check the accuracy of the model, that how much right it is predicting. Okay, now we will see another thing. Okay, in the data set, I am telling the term data set. If we see the data set, first we divide the data set in, we split the data set in two parts. Okay, one is training data set, another is test data set. Okay. I give some value, that is I take 80% of my data as training, I take 20% for testing purpose. Okay, what is this training and testing data set? Training means I am training the model with this data, 80% data set. Okay, and testing means I am giving the 20% of the data to my model to see how much it is predicting right or wrong. Okay, so there is train data set and test data set. In train data set, we also divide the train data set into another thing that is known as validation data set. Okay, validation data set. This validated data set used in hyperparameter tuning. So I will make a video. On this validation data set, how it is doing the hyperparameter tuning, or what is the hyperparameter tuning. Okay, I will make this video. So we need not to focus on that here. Okay, we focus on the training data set and testing data set. Now, if we see in my training data, my model is performing very good in my training data set, training, and the model is performing bad in test data set. Suppose I give my train data set, I give my train data set to the data, I give my test data set, my accuracy is coming low in test data set. So this comes to a condition known as overfitting. 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 Okay, and another case is the underfitting concept. Underfitting means model is also performing bad in both train and test. So it is underfitting concept. And perform good model means both are good. Training model is performing good, test model is good, so it is good data. Okay, good model. So we have come one term known as overfitting, another term known as underfitting. What is overfitting? Model performing good in training, model performing bad in test, and bad underfitting means both bad in training and testing dataset. Okay, now to reduce this overfitting, we use regularization concept. To reduce overfitting, we use regularization. We use regularization. Okay, there are two regularization. One is reg, that is my L2 regularization. Another is lasso, that is L1 regularization. What is this? Region lasso regularization. Okay, in lasso in reg regularization, we see what my the data is overfitting. That is the model is training model is performing good, but test model is bad. In case of linear regression, we are seeing that. Now we apply this reg and lasso regularization. Okay, lead and lasso regularization. We perform lead and lasso regularization. In lead regularization, what we do? We have seen the cost function j. Okay, theta 0 and theta 1. In that cost function, we change some little thing of linear regression cost function. We change some little thing, that is h theta of x minus y. This was my cost function. This is my whole square. We add one lambda, that is my hyperparameter, into slope square. Lambda into slope square. Okay, so this is giving me overfitting. This cost function in linear regression, we add this term L lambda. This is my parameter. Okay, lambda parameter, we can select this parameter into slope square. We add this, so my overfitting is getting reduced by regression, regularization, regularization. And in lasso regularization, the same thing. We are in the cost function, we are adding theta of x minus y. We got the cost function of same as linear regression cost function, plus we take lambda mod slope. That means what? This plus lambda is reducing my overfitting. And why mod here? It is reducing overfitting as well as it helps in feature selection. That means if we see the feature that have negative values, the modulus will give it positive, the negative values gets positive, so that features will get automatically deleted. So it also helps in feature selection as well as to reduce the overfitting. And regularization only helps in reducing overfitting. Only reduce overfitting. Here feature selection as well as overfitting reduce. Okay, so this regression and ratio regularization. Okay, okay, so if we get overfitting in linear regression, we will apply regularization concept, that is L1 and L2 regularization, to prevent the overfitting. Now we go to another thing, algorithm known as logistic regression. Okay, logistic regression. This logistic regression helps in classification problems. This logistic regression does classification problems. Okay, now if I draw a graph using the data points in the data set, okay, I will have two things in my feature, like yes or no. So this is my no and this is my yes. 2 points I have, and in linear regression you used to have many points because these are my continuous variables, but here we get two things, that is yes or no or multi-binary classification. Suppose three things we need to classify, true or false, like that. Okay, now I will not have the datas in between these points. Okay, these points I will not have the data here. I will have my datas only on, I will not have my data here. Okay, I will have my datas on these points only, yes or no points. Okay, I will have my data here. Now if I try to draw that best fit line using the linear regression, I will draw. Okay, the points are like this. Points are like, I will try to draw the graph. Now I have my point over here. My graph changes to here. Okay, by linear regression, if we try to draw the graph, so changes. So we have to change some little thing. Is we need to squash this graph like this. Squash this graph so such that it becomes like this. So it becomes like this. Like this. My graph becomes like this. It goes and it squashes. Okay, my graph becomes like this. So this is known as, this curve is known as sigmoid curve or logistic curve. Sigmoid curve or logistic curve. And the equation of this curve is h theta of x, that is my y variable, is equal to 1 by 1 plus e to the power minus theta 0 plus theta 1 into x. Okay, this is my y and this is my value. Okay, sigmoid function, or we can also write this formula as y equal to 1 plus e to the power minus z. Minus z is what? This theta 0 plus theta 1 into x. So this is my equation of this sigmoid curve or this logistic curve. Okay, now we need to draw this curve such that we get the best fit line, so that the distance between the point is minimum. For that we need to calculate what? The cost function. The cost function. Now if we use the cost functions that we have used in linear regression, like this cost function, if we use, okay, in h theta of x we put 1, I am telling you, suppose this is my cost function, this is my cost function. Okay, this is my cost function. I use in 1 by 2m h theta of x, I use 1 by 1 plus e to the power minus z. My predicted point, this is my predicted point and this is my real point. Okay, this is my real point. So if I subtract it, if I use this cost function, convert the linear regression cost function into logistic regression cost function, what will happen? We will get a non-convex function like this. So here various local minimas are there, local minima, and we cannot find the global minima, that is the theta 0 and theta 1 value. This is my non-convex function. Okay, theta 0 value. So for that we use another cost function. Formula is j theta 0 theta 1 is equal to minus 1 by 2m y into log h theta of x plus 1 minus y log of 1 minus h theta of x, h theta of x. This is my cost function. Now using this cost functions, I will draw by the gradient descent curve. Okay, I will draw the gradient descent curve. I will get my this gradient descent curve. Now I will be standing here. I need to reach my global minima, that is the theta 1 theta 0 value, for which we can draw the best fit line. For that we have to use the same gradient descent formula, gradient descent algorithm. We reach here, so this is my global minimum. Okay, so in logistic regression, simple change, we need to draw a sigmoid function. In that sigmoid function, we used to get that best fit sigmoid function, sigmoid curve. For that we need to calculate the cost function. After calculating the cost function, this formula, we get a gradient descent curve. In the gradient descent curve, we are standing here. We need to apply the gradient descent algorithm to move to the global minima, and we will get the point theta 0, theta 1. We draw the best fit line. Okay, now performance of the classification algorithm. Performance of classification. We have done the performance of regression algorithm. We have also need to do the performance of all classification algorithm. Classification algorithm. Okay. We use, first thing is that confusion matrix. Confusion matrix is the main thing. Okay, I say that confusion matrix is the main thing. From confusion matrix, we try to predict, calculate the accuracy, we calculate the precision, we calculate the recall, and we calculate the F beta score, F2 score. Okay, from the confusion matrix. Now, how to draw this confusion matrix from algorithm? Okay, suppose I have my data points. I have my features. My features are F1 and F2, and F2 features I have, and I have my output. Okay, in my, there are various data points, and my output point is what? Suppose I have my data set like F1 and F2. My two features are there, F1 and F2. I have my output. Okay, I have my output. Now I divide this output into two things. What are the two things? My output. In the cost function, we have seen that we have the, this is my predicted point and this is my real point. Okay, my predicted and this is my real point. Now I take the predicted output and my real output. I take the predicted output and my real output. I convert the output into two, predicted output and real output. Okay, predicted output and my real output. Now in predicted and real output, what I do is that in predicted and real output, if you see, I have function 1 in predicted, 1 0 1 1. Okay, 1 1 0 1. In my real output 0 1 0 1 1. Okay, ठीक है. अब क्या होगा? From this predicted and output, we try to draw matrix. We know what is matrix. In this matrix. Okay, so this is my 1 0. 1 means what? True. and 0 means what? False or yes or no, if I say. And this is my predicted, and this is my actual values, okay, my real values. So it is also here 1 0, okay, 1 0. Okay, now I take my predicted point is 1 and my real point is 0. Okay, so this is my predicted point and real point. Okay, the predicted point becomes 1. This is my predicted and my real point is here 0. So 1 0, 1 and 0 here. I make the count as 1. 1 1, 1 and 1. I make the count as 1. 0 0, 0 0. That means here make the count as 1. 1 1. I make the count as 2. Okay. Next 1 1. I make the count as 3. Okay. So this actual and predicted value, if we draw a matrix, this is known as the confusion matrix. Okay. Now in confusion matrix, how we calculate the accuracy? Accuracy is what? If we see the confusion matrix, so it is predicting 1 and actual is 1. This is right, this is true, and 1 is what? Positive value. It is predicting 0 here. If you see here, it is predicting 0 and 0. It is predicting true value, and 0 is what? Negative, negative. Now here I come. This is 1 and this is 0. This is 1 true, 1 and 0. That means it is predicting false value. Okay, false value. Okay, and my here value is 1. That means it is positive. It is 0 and it is 1, predicting false value here, and my point is where 0, that is negative. So this is my true positive, false positive, true negative, false negative, and true negative. Now how to calculate this accuracy score? Accuracy score is what? Accuracy is what? True positive plus true negative by true positive, true negative plus false positive plus false negative. Okay, true positive plus true negative, by we get the accuracy. Now what is this precision value? We check. Okay. The precision value is what? Precision is nothing. It depends on the precision. The formula for calculating precision is true positive by true positive plus false positive. This is my calculating prediction. How it is true? Recall value is what? True positive dependent on true positive and false negative. We see the true positive, how it is different from the false positive in precision, and in recall, if we see the true positive, how it is different from the false negative. So it is the difference between true and precision and recall. And F2 score is what? F2 score formula is what? F2 score, if I say F2 means one parameter, I say this parameter is beta, and this formula is 1 plus beta square precision into recall by precision plus recall. Now if I put beta is 2, so it is 1 plus 2 square, that is 4 plus 1 5, precision into recall. Here also beta square will come, beta square into precision plus recall by 4 precision plus recall. So this is my F2 score we calculate. These are my performance parameters to check precision, recall, and F2 score. Okay. Okay. So up to this, the two algorithms I have taught, linear regression and logistic regression. In the next class, we will see the practical implementation of this. And after that, we will see the other algorithms. Okay. So if you have liked my videos, subscribe my channel so that I could create more videos. The motivation is required to create the more videos, and I will be creating more videos on machine learning. After the machine learning I complete, I will create deep learning, NLP, computer vision, etc. Okay, and thank you for that today's video.